FAE for VeEX. So thanks for attending this session. So the subject is ensuring fiber integrity with the VeEX OTDR. By the way, if you guys have any questions, please use the chat box at the end of this presentation. We'll try to address your questions. All right, so here is the agenda. I'll go over the OTDR basics, distance measurements, reflectance, and ORL measurements. Then we'll go over how to use the VeEX OTDR. There are some setup parameters that you could choose. So VeEX allows the user, a novice user or an expert user, to manipulate the settings as they wish. And lastly, we'll go over the different OTDR's test solutions available. So let's start off with the basics. So an OTDR stands for optical time domain reflectometer. So what is it? It's a fiber optic test tool that is essential for anyone who deals with fiber. So you may or may not use it personally, but you at least have had some exposure to it. So an OTDR uses a high power laser transmitter that sends a pulse of light down the fiber and measures the backscatter. And through that process, it's able to locate any of the events along that fiber. So there are a number of reasons why you would use an OTDR. Determine the overall distance of the fiber, determine the location of the faults, the defects, or any events along the fiber as well. Determine what kind of events can happen at what distance. So an OTDR can also calculate the loss of each of these events. So we have a measure tab that will have markers, and depending on where you place the markers, it will give you measurements from an A marker and B marker side. So a reflective event is a mechanical splice or a connector loss. So these will look like a spike in the trace. That basically indicates there's an air gap at that location. So a non-reflective event is a splice or a macro bend. So you'll see a drop in the trace, or in some cases a gain in the trace if it's a gainer, and we'll discuss that as well. So using if you use multiple wavelengths, you would tell if there is a macro bend. So with these reasons in mind, you can use the OTDR to troubleshoot your system. So when there is excessive loss, you need to troubleshoot why there's an excessive loss. Is it a bad connector? Is it a bad splice? So it also allows you to verify your system. So how many splices, connectors, any events along the fiber are in place. And then the majority of the time, you also want to know what the whole total length of the fiber. So also to tell you and determine the overall distance of the fiber under test. And lastly, you can also document these results. And VeEX provides where you can document it in a PDF format. The traces will be there. Your list of events will be there. And this will be your, you can serve this as like a birth certificate. So if months down the line, if the fiber is no longer working, you can provide information when the test was taken that your test was good. So what is the distance range an OTDR can shoot? So this question gets asked quite a bit. So I'll just kind of go over this part. This is the OTDR is really spec'd and measured in terms of dynamic range. and these are expressed in dB. The dynamic range will tell you how much the OTDR can handle, the loss, how much it can handle. So if you've got multiple connectors, bad connector splices, now your distance will be impacted, so you won't go as far. So that will limit the distance because of the loss factor. If you've got a splitter or a mux in the system, your distance will be impacted. But still, a lot of people still ask, so how long can the OTDR shoot? So using a typical loss, in this case, 0.35 dB per kilometer for 1310 and 0.22 kilometer for 1550. I've got a table here that our PLM team provided to show as far as dynamic range in terms from 30 dB, 35 dB, 40 dB, and 45 dB. So using a 20 microsecond pulse width at low resolution at a time of 3-minute acquisition, you can see there at the bottom how far the OTDR can shoot. So keep in mind that this is in a DL fiber situation where it's a continuous span. So in reality, there's going to be a lot of events in the fiber. So these will impact how far your distance can go. But if you want to calculate the distance itself, there's the distance calculator, dynamic range divided by your dB per kilometer. So let's go over the events, what kind of events you would see on an OTDR trace. As mentioned earlier, there's a reflective and non-reflective event. So looking at this trace here, on the x-axis, you have the distance. On the y-axis, you have the return loss, your return signal. The trace will provide a downward slope from left to right. The slope factor is determined by the fiber's vendor attenuation coefficient. So if you're splicing two different vendors together, you may see a slight variation in slope. And this will skew your loss measurement. This is why you would do a bidirectional test and determine a real, true actual loss at any event. So looking at the beginning of this trace, you have the launch reflective event. So you'll always have a launch reflective event because whatever you're connecting your OTDR to the first connection at the fiber under test, you'll get that air gap. So we always recommend using a launch reel. That way you can determine the loss at the first connector. So the next event you see here is a reflective event. So this is where an air gap exists. Usually this indicates a connector or a mechanical splice. Then you have a non-reflective event, which could be either a fusion splice or a macro bin if you're using multiple different wavelengths to compare them to. Then at the end, you have another reflective event, and this is followed by the noise. So that basically tells you that's the end of your cable there, your end of your fiber. So in the VeEX OTDR, for example, this is kind of what the GUI will look like. You can see the non-reflective event in this trace. You can also see where the fiber span begins with that open bracket on the left hand, and then also the closed bracket will determine will also denote that you are at the end. And then in this events tab, you'll also notice the table here that also will go through the number of events. And at the bottom here, it tells you the overall length, overall loss, your ORL, and your latency. VeEX also has the ability to show the fiber events in a link map icon-based diagram. So from gathering the data information on the traces, the OTDR is able to build a best guess on what any of these events are. So you can click on each one of these icons and it will tell you what the event is. For instance, and this is the beginning, and then if you click on this next one, this will identify as an APC connector. And with the red there, it just means that your pass-fail threshold is exceeded. So that's why it's giving you that little red alarm. So another measurement that OTDR will display is going to be your optical return loss. So what is the optical return loss? It's basically your OTDR providing value that is a positive value, and it'll be expressed in dB. So this measures the amount of light that gets injected into the fiber and compares it to what is being received back. So looking at this trace, you can see that under this whole trace is a summation of the area underneath in respect to the noise floor. So calculating that trace will give you the optical return loss. So the higher the number for the optical return loss, the better your performance. So as far as VeEX OTDR and how to optimize the settings to set up a test. So if you have seen one of our OTDRs before, you'll notice that the GUI is very much similar throughout our platform. So in this case here, you'll land on the setup tab, this setup menu, and simply you can just select the different OTDR wavelengths there at the top and select it to be in auto mode. And this is a great feature that is, if you don't know the distance of your fiber, select an auto mode and then just hit start. And right then it'll give you a view of your trace. So it does a countdown of 30 seconds for each trace, and then it'll build the diagram. So all you have to do is, now if you want to change the method, there's multiple modes out there that VeEX also has. So you can also make it make it for a novice user to use your auto, or if you have an expert user, you can make it in a manual mode. So in terms of the different types of modes, the user can manually enter any of the test parameters for their settings. Then there's also the vScout mode. The vScout is an intelligent way of the OTDR building a layout of the fiber under test through this algorithm. So it'll take multiple traces using different pulse width, and then from there it'll tell you, it'll put on a link map as far as what the layout will look like. Now you also have your manual real time. This allows OTDR to continuously run and scan using the user's settings. If you do it in auto real mode, this will allow the OTDR continuous run and do it with its auto settings. So what different types of fields can you change in manual mode? So these are okay, so this will be your distance, pulse width, resolution, time, and if you're gonna change it to be optimal for dead zone or dynamic range. So let's look at these settings a little further. For the wavelengths, VeEX has this different wavelengths you can choose from whenever you are gonna configure your OTDR. You can use it to be quad lasers, or you can choose your basic 1310 or 1550. Now we also have to note that we also have a CWDM or DWDM OTDR which is in our RXT platform, and this will go through all the CWDM channels and DWM channels in the ITU grid. So when selecting wavelengths, you should always shoot a trace at multiple wavelengths and compare them, because the higher wavelengths are more sensitive to your macro bending, and that's how you will define your macro bending. So in the picture on the right there, you'll notice that 1550 sees a greater loss than 1310, and 1625 sees a greater loss than 1550. So what about the distance? So you should always choose a distance that's greater than your fiber under test, and in this case, we would say at least 25% longer. That way you can identify your end of fiber. So you always also note that the fiber itself is going to be longer in your cable by 1%. So this is basically done to allow for temperature variations throughout the cable. And then pulse width. So this is one of the more important settings to choose from. So the rule of thumb when choosing pulse width is to choose a higher pulse width that you are, the higher the pulse width will be for the longer the distance. But the drawback is if you have this will produce a greater dead zone. So this will also follow so the dead zone is going to be a reflective event where it gets blinded and you can't see anything between that. So if you have two close events, the dead zone will cover that up and you will see more like a merged event. So you can also, if you have a shorter distance for a cable, you choose a shorter pulse width, because that will limit the dead zone and find any events that are close together. So the drawback for that is that you won't be able to shoot as far, and the trace, as you observe it, it'll get quite noisier. So as a reference, 10 nanosecond pulse width is about 1 meter in length, and 100 nanosecond is about 10 meters. So if you look at that picture on the right, that shows you how a pulse width versus a short pulse width, a long pulse width versus short pulse will look like when there are two events close together. Resolution. So this is another setting we could choose. For the resolution setting, you can make it either be your auto, the highest resolution, or the lowest resolution. So what this means that since some of our test sets can have as much as 500,000 data points, that basically says OTDR can collect more data on a trace and it can be more accurate. So if you look at that top picture, you can see that you can collect more data, and anything within the falls between those vertical lines, that's where it's gonna take the measurements. And the one below is a OTDR that's taking a less data resolutions. So the measurement time. So the longer you set the time, the more averaging takes place, the more acquisition will take place. Thus, you'll have a cleaner trace. If you set the longer the test time, the slower the scan, which is in this case, it'll be a slow scan, and you have a cleaner trace, but you could be wasting time that you don't need to. So if you set a shorter time, which will be a fast scan here, you'll be able to do it quicker, but your trace may be too noisy. So a user has to find that balance of find the shortest time that will produce a usable clean trace. So on our VeEX settings, we also have the settings to optimize for dead zone. And you can set it for auto, and this will have the OTDR choose to be for dynamic range, optimized for dynamic range, or optimized for dead zone. So one reason you want to do for optimized for dynamic range, because it will result in a lower noise floor, which will allow you to shoot further. But if you do it optimized for dead zone, it will do a higher noise floor, but shoots but it'll be able to see a limit to your dead zone. So if you look at the picture of those two events there, where I have those two arrows, you can see that the green trace is optimized for dead or dynamic range, and then the blue trace is optimized for dead zone. So the blue trace produces less dead zones, so you should be able to see events closer together if one was to take place there. So VeEX has some accolades to boast about. Our OTDRs have got some good reviews from Lightwaves in the past, and we'll go over the different types of platforms that are available. So first off, we'll start off with the OPX Box E OTDR. You'll see there at the top right. That is our screenless, faceless OTDR. So you can tether this with any of our test platform and use that test platform as a screen. You can also use your mobile device that has either Android or Apple iOS, and you'll have to download the Fiberizer application to run these. Connectivity is through Bluetooth or Wi-Fi. You could also direct connect to a PC or also your Android device. So what you see the next two there is our more popular OTDR units. We have a FX150 Plus, and then the one at the bottom there is the MTT 410 Plus. So the main difference is one is fixed, which is the FX150 there in the middle, and then the bottom one is modular. So you could take out these modules and put another test module in there if you want to do Ethernet testing or Wi-Fi testing. We have modules for those. And then the other thing is the MTT Plus is a little bit bigger as far as screen size go, and then it also allows for more data points. Then we transition over to our TX300 platform. So this one is the TX300 platform itself has slots for 2 modules. You can pair your OTDR module with an Ethernet test set if you want to do 2 different test scenarios. The only thing is the TX300 is a fixed platform just like the FX, so you can't take any of the modules out. They're already fixed from the factory. And then we have our modular platform, which you see there in the bottom, which is going to be our RXT. So our RXT has multiple OTDR modules. It's got 5 of them. So you got your basic OTDRs, 4100 plus, and then you got your CWDM and DWDM modules. And you also have a combined CWDM DWDM module, which you see at the 4113 and 4114. And why would you want to use the CWDM or DWDM modules or the OTDR? It's because if you want to, since these can be tuned to a wavelength that you choose, you can shoot it through any of the muxes that are wavelength specific, and you can go through any of the head-in, and you can go through a ROADM, and then you can decide from the trace itself, see how far the end is, your fiber end. So this kind of shows you a product positioning as far as our OTDR solutions. So going through from the bottom up is also price-wise for a more budget-friendly to the more technology advanced, the RXT. So you kind of see where you would fall in this space, and you could choose which test modules you need. And that's all I have. So do we have any questions that we can go over?
Yes, we have a question from, we have a question about how are the calibration of, what are the calibration of the OTDRs? And is it done using a recycled delayed line?
So calibration wise, well, if you use it just depends on how often you use your OTDRs. If you use it on a daily basis, you know, we recommend doing a 1-year calibration because your connectors may be dirty, or the inside connector. So you just got to, that's something that we need to we will check whenever you do calibrate. So if you don't use it often, because the optical components itself doesn't change very, or doesn't it doesn't degrade that easily. So as far as calibration goes, just depends on how often you use it, really.
So some additional questions are, how do you measure ORL on an OTDR if you can't remember seeing a button? So this
the ORL is calculated within the OTDR itself. So that's measured by just taking all the reflective events that so it shoots down a pulse of light, and any all the backscattering reflective events that comes back. Now it's got an internal calculation algorithm that will go through, and it'll provide that in the on your screen. If you see the GUI, it'll be at the bottom of your events trace. So that's going to be your whole summation of all the reflective events.
Yeah, so let us know if you have any more questions. Yeah, so they're wondering, where does it show the value?
Okay, let's see if I could go back. For the ORL?
Yeah, for the ORL.
Okay, so in this case here, you can look at the link map, and it's the bottom here. Now, what I have, I've actually minimized this. If I was to make this table pop up, so instead of actually, I think I have right here. Here we go. So it will tell you here at the bottom ORL right here. This is your overall calculations, your distance, loss, and ORL, as well as your latency.
Great, okay. I hope that was cleared up, and if we don't have any more questions, we're going to be ending this session. Thank you for joining us. You'll all receive a copy of the video, and have a good day.